Hello, Mr. Sutton here with the Pre-Cal Honors 9-5 Extra Practice Number 1 solutions on limits at infinity. On this problem, the line y equals 5 is a horizontal asymptote to the graph of which of the following functions. So we have to look through all of these and see which one has a horizontal asymptote of y equals 5. So for all of these, we're considering the limit as x approaches infinity, and possibly negative infinity if that's not enough to narrow it down to one choice. So for here, this first one, choice A, we have sine over x. Well, sine just fluctuates between negative and positive 1. X grows forever. So this is a bottom-heavy function, which means we have a horizontal asymptote of y equals 0 on this one, and that's it. For this next one, choice B, if you consider this as being 5x over 1, this kind of counts as a top-heavy function. So it has no horizontal asymptote. And I mean, if you think about it, this is just a line. It's growing forever, up and slanted. So you don't have a horizontal asymptote there. This one is bottom heavy again. So we have a horizontal asymptote of y equals 0. Choice D, well, we have the same degree here. So if we just consider 5x and negative x, we can forget about the 1 as x approaches infinity. This has a horizontal asymptote, if we cancel out those x's, of negative 5. So that's better than any of these other ones, but it's still not quite what we want. Let's check out this last one. For this last one, as x approaches infinity, we can disregard the negative x and the 1 because those are slower growing terms. So we really just have the 20x squared over 4x squared as x approaches infinity. And this just reduces flat out to y equals 5. So choice E then is what we're looking for. For this problem, f is this rational function here, and they're saying the line y equals b is a horizontal asymptote, and they want to know what b is. So essentially, we have to figure out the limit as x approaches infinity of this thing. So to do that, I'm just going to kind of look ahead a little bit if I were to actually multiply all this out. I'm not going to do everything, but at the very least, I know that if I do x times 2x, I'm going to have the highest degree term in the numerator of 2x squared. And down here, if I multiply everything out, I'll end up with an x squared to start it all off. So we just have to consider the fastest growing terms in the top and the bottom. So 2x squared in the numerator, x squared in the denominator. That's all we're considering as x approaches infinity. And I can now cancel out my x squareds to get a horizontal asymptote of y equals 2. So that's choice C. For this problem, we're told that the vertical line x equals 2 is an asymptote for the graph of f. Based off of that, which of the following statements must be false? So just considering what this means, if we have an asymptote at x equals 2, that means the limit as x approaches 2, which a lot of these answer choices are talking about, must come out to either positive infinity if we're going up on both ends, negative infinity if it's converging downwards on that asymptote, or DNE if they're going opposite directions for each branch. So these are really our three options as x approaches 2. So taking a look at our answer choices, well, B and C could be true, because again, it could be any of these. D could be true. We don't really know anything about what's happening as we go to infinity either way. The only thing that has to be false, as x approaches 2, we're getting some constant here in choice A. That can't happen. It needs to be infinity, negative infinity, or DNE. So since we can't have a constant limit at a vertical asymptote, choice A is the only one that has to be false. For this one, we're given this weird function, sine of x plus 1 over x squared. Not a calculator question, so we have to figure this out with a little bit of limit analysis. Based off of this statement, we want to know which of these is true. So we have the graph has a horizontal asymptote at 0 or 1. Those probably aren't both true, and you'll notice there are no answer choices that have options 1 and 2 both in them. And then we have option 3, vertical asymptote at 0. All right, well, let's deal with the horizontal asymptote first. That should at least narrow it down a little bit. So we need the limit as x approaches infinity of this stuff. And as x approaches infinity, we can forget about the 1 here. So we're really just dealing with x over x squared, the champions on each side of this fraction. And that's really just 1 over x if you reduce that. Now, as x grows to infinity, 1 over infinity is just 0. So we're just doing sine of 0, which comes out to 0. And you would get exactly the same sort of thing if you did x approaching negative infinity as well. So it's not like you have a different horizontal asymptote going the other way. You really just have one horizontal asymptote at y equals 0, which that means 1 is in and 2 is out. So our answers could be A or D. That's really it. So it just comes down to whether or not our graph has a vertical asymptote at x equals 0. Now it's tempting to say so because when you plug 0 in for x, you get a 0 in the denominator. And typically that does give you a vertical asymptote, at least if you have a rational function. This is not a standard rational function though. This is a rational function inside a sine function. And the interesting thing about sine is that whatever you plug into it, it can only give you back a number between -1 and +1. Well, if you're limited between these y values, that means that you can't go to infinity or negative infinity. You might get some other kind of weird discontinuity or hole or something, but you can't get vertical asymptotes if you're not growing to infinity or negative infinity. So therefore, option 3 is no good. Only option 1 works, so choice A. On this problem, we're given an infinite series, and they're telling us that the nth partial sum of this series is n over 3n plus 1 for all n values greater than or equal to 1. Based off of that, they want to know the sum of the series from 1 to infinity. So they're telling you how to find the nth sum, and we want the infinite sum. That means we need to take the limit of this expression as n approaches infinity and see if we can get some kind of number out of this. So since I've got a 3n plus 1 here, in this denominator, I can actually ignore that 1. Since my n is approaching infinity, I'm allowed to ignore the slower growing terms, or the not growing at all terms in this case. So this is really just n over 3n, which I can reduce to 1/3. So that ends up being the infinite sum of this series, which gives us answer choice A. On this one, we're asking for which pair of functions f and g is f of x over g of x, limit as x approaches infinity, infinite. So if this whole thing is coming out to infinity, it must mean we have a top-heavy function, which is to say we need f to grow faster than g. So keeping that in mind, let's look through all the answer choices. Choice A, we have x squared plus 2x versus x squared plus ln of x. Now, when we're talking about growing faster, we're talking about as each of these individually approaches infinity. So if you do that, you're just going to forget about the 2x and the ln of x, and you're just comparing x squared and x squared. Dividing that would just give us 1, so this is not going to give us infinity. Down here, we have 3x cubed versus x to the 4th. Well, we have a bottom-heavy function with this one. X to the 4th grows faster than x cubed. So this would come out to 0, not infinity. For this one, we have 3 to the x over x cubed. Now, exponential functions far outpace polynomial functions. So this is top-heavy. This is the kind of function we're looking for. So choice C is looking pretty good at this point. But let's check out the other ones. So D, we have 3e to the x plus something, and then versus 2e to the x plus something. Well, we're going to forget about everything except these e to the x's. And then dividing those, you would just end up with essentially 3 over 2 after you cancel out the e to the x's. So that's not going to work. And then down here, these ln's, you could split each of these up. This is really ln of 3 plus ln of x. This is ln of 2 plus ln of x. So you basically, when you forget about those ln constants, you're just doing ln of x over itself, which is just 1. So this also is not growing fast enough to get to infinity. So when all said and done then, choice C is the only one that makes sense. For this problem, we're taking the limit as x approaches infinity of this mix of functions here. So we're going to start by doing choose your champion. We're going to ignore the slower growing terms in the numerator and denominator. Denominator, I mean, x is it. There's nothing else. But in the numerator, we have inside the ln of x here, we have an e to the 3x plus an x. Now, as x approaches infinity, this e to the 3x is going to grow way faster than this x. So this x, we can just kind of ignore this one and call this whole thing limit as x approaches infinity of just ln of e to the 3x over x. That's what this thing is going to behave like. All right, we can go a little bit further now. ln and e are going to cancel out, leaving us with just 3x in the numerator. and then we can cancel out the x's to leave us with just a limit of 3. So that's choice C. For this problem, we want to know which of these functions' graphs has exactly one horizontal asymptote and no vertical asymptotes. So we're going to analyze asymptotes for all 4 of these. Let's look at the first one. Now for vertical asymptotes, you're essentially figuring out what's going to make the denominator 0, assuming we don't have any common factors that are going to cancel. And if you look at all these, we have a constant in the numerator for all of these. So there's going to be no common factors canceling. There's going to be no holes. Anything that makes the denominator 0 on these is going to be a vertical asymptote. So having said that, looking at our first function here, x squared plus 1, if you set that equal to 0, there's no way to find an x value that solves that. You end up with an imaginary number. Since x squared the smallest value this can be is 0. So because x squared plus 0 has no solution, we have no vertical asymptote for this first problem, which matches what we're looking for with the conditions. Now let's talk about the horizontal asymptote. This is a bottom-heavy function, so the horizontal asymptote on this one, just using basic pre-calculus reasoning, is going to end up being 0. So this is actually looking like a pretty good one. We're going to say this is a yes for now. Let's see if there's a better answer choice out there, or if we can eliminate the other ones. For this next one, we're going to have a vertical asymptote at x equals -1. -1 cubed plus 1 would give us 0. So that would be our vertical asymptote for this one. Because we have one vertical asymptote instead of no vertical asymptotes, choice B can immediately be eliminated. For choice C, well, is there anything I could raise e to turn this into a 1 and cancel out this other one? Well, yeah, e to the 0 power is 1. So we have a vertical asymptote then at x equals 1 because that would make our denominator 0. So that means C can also be eliminated because we're not supposed to have a vertical asymptote. Now for D, e, you might remember, can't even be 0. E to the x is always a positive function. So because of that, e to the x plus 1, there's no way to turn that into 0, and we have no vertical asymptote for this one. So this is still in the running. Let's take a look at the horizontal asymptotes. Now to do that with an exponential function, because exponential functions behave differently as you move to the far left and the far right, you have to consider both negative and positive infinite limits for this one. So considering first the limit as x approaches infinity of this function here, that's going to be, since this is a bottom-heavy function, that's going to be 0. Now as x approaches negative infinity, things are looking a little bit different because now you're doing e to the negative infinity essentially. So we can rewrite this whole thing as 1 over e to the infinity minus 1. This is really e to the negative infinity. So this exponential term just goes to 0, leaving us with 1 over -1, which comes out to -1. This is a second distinct horizontal asymptote from this first one up here. So we have one asymptote as we move to the far right, a different one as we move to the left, two horizontal asymptotes instead of the one that we wanted here. So that's how we eliminate choice D, which leaves us only with choice A. On this one, the continuous function f is positive and has domain greater than 0 if the asymptotes of our graph are x equals 0 and y equals 2. Which of these statements is true? So you can do this without drawing a graph, but I think a graph makes it a little bit easier to visualize. So here's a graph with a horizontal asymptote at y equals 2. I didn't label anything, but there it is. And then we don't need to draw anything for the vertical asymptote because that's just the y-axis. Now in terms of what our function looks like here, they said that our continuous function f is positive. So that means that we must be above the x-axis. And the domain was x greater than 0, so the x values are positive, meaning we must be to the right of the y-axis. Well, if I'm over here and I'm always positive, that means I have to have a function that looks like this. I can't be down here because then I would have negative pieces of my function in order to approach only this asymptote and also this asymptote. So there's our picture. Let's analyze what's going on now. The vertical asymptote piece of this, that's telling us about the limit as x approaches 0 from the right side. And we see that as we do approach that asymptote from the right side, our y values are going to positive infinity. So that narrows down our answer choices to, it looks like, A and C. Now we have to figure out the limit as x approaches either infinity or 2. Well, as x approaches 2, we're definitely not going to infinity. So choice A could be eliminated pretty quickly. But let's talk a little bit about choice C. Now, this horizontal asymptote is what gives us a little insight on the limit as x approaches infinity. Because with a horizontal asymptote, the limit as x approaches infinity is going to be whatever that asymptote is. So that's going to be 2 in this case. So matching that up with one of our answer choices, it looks like that is going to match answer choice C. On this problem, we're trying to find the limit as x approaches infinity of this rational looking kind of function. It's not a true rational function because of the exponential, but it's a fraction. So because it's a fraction, we're going to use some choose your champion kind of reasoning here. We'll pick the fastest growing term on both sides of the fraction. In the numerator, we have negative 6x squared as our faster growing function. The 10 can be ignored. And in the denominator, in this corner, we have just the 3e to the x. The 5 also is insignificant as x approaches infinity. And we can't really reduce this, so we have to use the relative rates of growth kind of reasoning, seeing which one goes faster. And between the two of these, we have a polynomial versus an exponential. We know the exponential is going to grow faster. So this is a bottom-heavy function then, which means that if my denominator is growing compared to my numerator, this fraction is getting closer and closer to 0. So that's going to be choice B.